Alright, hello grade 9s. Just before people go to school today, I just thought let's do let's look at a paper here for grade 9s. That is a paper that was done, I think last year's test, grade 9 2024 King Cetshwayo District. I just want to go over this paper so that those who are in grade 9 that may be writing, we may be able to assist just as you prepare to go to school. I just want to, for a moment, look at some. Okay, there we go. As it says there, various options are provided as possible answers to the following questions. Choose the correct answer. Write only the letter next to the question number. Example 1.1.11 D. Okay, 1.1, the question says, from the given graph below, find the correct equation that represents the graph where its gradient is m is equal to 2 over 3. Find the correct what? Equation where the graph, find the correct equation that represents the graph where its gradient is m is equal to 2 over 3. So we're looking at 1.1, and if you look at the graph itself, if we look at the graph itself, look at the coordinates of the graph. There's a y-intercept of 2. So there's the coordinates of the y-intercept are 0 and 2. And we are asked to find the appropriate equation that would define this graph. Okay, and there are our options at the top. We have A, y is equal to negative 2 over 3x plus 2. Could that be the equation of the graph? B, y is equal to 2 over 3x plus 3. C, we have y is equal to 2 over 3x plus 2. And then lastly, D, y is equal to negative 2 over 3x minus 2. Which appropriate option would be relevant to define the equation of the graph that you see there? Look at it. The graph is an increasing line, 1, 2, the gradient, as they say, is 2 over 3. And then additionally, from the graph itself, we can see that the line cuts through the y-axis at 0 and 2. So which equation will best define the graph that you see there? The gradient is 2 over 3. The y-intercept is basically 2. Or in other words, the coordinates of the y-intercept are 0 and 2. So is it A, y is equal to negative 2 over 3x plus 2? B, y is equal to 2 over 3x plus 3? C, y is equal to 2 over 3x plus 2? Or is it D, y is equal to negative 2 over 3x minus 2? So hopefully we can see, guys, that letter A and letter D can't be the answer. Why is it that letter A and letter D can't be the answer? If we look at the gradient, okay, remember the standard form of an equation for a straight line is y is equal to mx plus c, where in that standard form m stands for the gradient, c stands for the value of the y-intercept. So if they are saying in the statement that the gradient is supposed to be 2 over 3, if we look at A and D, option A and D both have a gradient of negative 2 over 3. So that means A and D can't be the correct answer. So we can eliminate A and D. They are not even an option. Though, if we look at A, our equation has plus 2 at the end, which is the y-intercept of the actual equation of the graph that we see. Okay, because the coordinates of the y-intercept are 0 and 2. But even that said, A can't be the option because the gradient is negative 2 over 3. So A and D are out. So we only have two options that we can look at, and that is B and C. Now if we look at B, the gradient there is correct. The gradient is 2 over 3. But the y-intercept is positive 3. So that option B is also eliminated. So the only option that we have there is the option C. If you look at C, guys, the equation of that graph is y is equal to 2 over 3x plus 2. All right. And now we ask ourselves the question, does this equation of the graph make sense if we look at the fact that the gradient must be 2 over 3 and the y-intercept must be positive 2? Yes, guys. You see, so C is our option. All right, C. So we need to then say the option C is the answer for 1.1. I hope that makes sense. So that's why we choose C. Not A, not B, not D, but option C. Why? Because the gradient there is 2 over 3. And the y-intercept as well is positive 2. And it is exactly what we see on the sketch on our graph. Okay, yeah. I just want to re-emphasize this point, guys. It's a very important point that we need to make sure that we are able to arrive at. Like I said, guys, the standard form for any equation of a straight line is y is equal to mx plus what? Plus c. When the equation of a straight line is in this form, this m stands for gradient. But only when the equation is in this form. This is the gradient. Okay? And then this c value is actually the value of the y-intercept. So the y-intercept there, guys, is 2, right? And we were told that the gradient is 2 over 3. So if we look at the graph itself, it cuts through 0 and 2, which means if we look at the equation, it has to be 2 over 3x plus 2. So that's why we chose option C as our answer to define the equation of the straight line. The gradient is 2 over 3, as we were told that the gradient is 2 over 3. And the y-intercept, what is the y-intercept? It's where the graph cuts or overlaps or intersects the y-axis. Okay, and so the y-coordinate always is the c value, the value of c. So it's positive 2 there, so that's why we have positive 2 there. Okay. Bianca, be live at 2 because you're struggling. What are you struggling with? Okay, let's go look at another question. People, look at 1.2. 1.2 says determine the correct graph that has an equation y is equal to negative x plus 1. Y is equal to what? Negative x plus 1. Look at A. Could it be that graph? Look at B. Yeah, well, if you think my answer was wrong, then it means that you don't know your work. I'm sorry to say. 409 King, whoever, you are saying that the answer is C is incorrect for 1.1. If you are saying that, then that means that there is a gap in your own knowledge when it comes to straight line graphs, and that's unfortunate, right? How can the answer C be incorrect? Maybe you can tell me, why are you saying C is incorrect? Maybe I can invite you, you must come. Why are you saying that if the straight line graph, okay, if you're saying C is the incorrect option, based on what reason? Please use better language. You see now you are swearing in the comment section, and I don't really appreciate that. You need to actually try and use more dignified language. When you use such language, it means that you lack vocabulary. You must be careful. All right. I don't really appreciate I don't really appreciate crude and vulgar and inappropriate language. Dignified language, can we? That S word that you used in the comment section, not appropriate. Okay, so yes, 1.1 is C, guys. It's C. All right, let's go to 1.2. Determine the correct graph that has an equation. Okay, y is equal to negative x plus 1. Okay, now look at A. Look at A. That's a decreasing straight line. Okay, it's a decreasing straight line. Yeah, which means for A, the gradient is a negative gradient. Look at B. B has a increasing straight line, which means it's a positive gradient straight line, right? C is a increasing straight line, which means the gradient is positive there. But look at the graph, it cuts through the origin, meaning it cuts through 0, 0, which means the y-intercept there is 0. Okay, and lastly, look at D. D is a decreasing straight line, and it means that the gradient is negative. Okay, now I just want to bring something to your guys' attention. You see 1.2 has a negative gradient. So if we look at our graphs, B and C can't be the answer. B and C, we can't write them as the answer. Why am I saying B and C can't be the answer? It's because both B and C are straight line graphs that are increasing. So in other words, it means that those two graphs have a positive gradient, guys. Those are two graphs, B and C, that have a positive gradient. Okay, yeah, I hope that makes a lot of sense. Okay, so I'm just gonna redraw these graphs so that maybe I can make my point a bit more valid there, so that you guys can appreciate this. So A, B, C, D. So guys, what I'm saying here is that if you look at the equation of the straight line, you see this equation? This equation 1 is in the standard form, y is equal to mx plus c. The m there, when it's in the standard form, means that that is the gradient. Okay, so here we can see that there's a negative gradient. In other words, the gradient is negative 1. Okay, by now we should all know, guys, when the gradient is positive, it means that the line is an increasing line. When the gradient is negative, our line is a decreasing line. Gradient is equal to 0. We have a horizontal line where C is constant. Okay, and then when M is undefined, or the gradient is undefined, we have a vertical line where the x value is the one that is constant. Okay, so here what we are looking at, since the gradient is negative and it's negative 1, we are expecting to have a line that is in this direction. It's a decreasing line. So immediately when I look at these A, B, C, D, and I'm wanting to choose an option for this line, it means that the B and the C are basically options that I can cancel out. Why can I cancel those options? Because these two options indicate straight lines that have a positive gradient, but this particular equation has a negative gradient. So that means A and D are the more suitable options. But then now I need to check. You see here we have the value of C. What does C stand for? I repeat, C is the y-intercept. In other words, where the graph cuts or crosses or overlaps the y-axis, where our straight line cuts the y-axis. Okay, so what I'm going to then say, A and C, A and D, if I'm looking at these two options, these are my only viable options now I can look at. This line is cutting the y value where y is positive, okay, which seems to align with this. But this line is cutting the y-axis where the y value is negative. So that means D cannot be my option. So the only freestanding option that I have then for y is equal to negative x, remember that stands for gradient. My gradient is negative. I'm expecting a decreasing line like this. So that makes a bit more sense, that this is the line. Or it could be this one. But because the C value is a what? Is a positive value. That means my y-intercept needs to be on the positive y-axis, not on the negative y-axis. Because here, this is a negative value that the graph is cutting through. But here, the value that the graph is cutting through on the y-axis is a positive value. So that means A is the option that is correct. Okay? Very straightforward and to the point. Okay, let me go. Okay. The 1.3 says, which of the following are mostly defined by the graphs shown below? Which of the following are mostly defined by the graphs below? Okay, so let's go. Let us go and check the full question that is being asked here. Let's go check these lines. Very important to go check these lines. Look at them. These are the lines, guys. Okay, very important. Okay, we have one that passes through the origin for A. The other one cuts through below the origin, and the other one cuts through just below that one. Okay, we have B. Look at those lines, guys. Look at them. Look at them. We have one that cuts through the origin. We have another one that cuts just above it. And then the other one that cuts that above it. But if you can see all these lines, A and B, the lines there that are drawn are parallel to each other. Very important to note that. Look at C. We have one that cuts through the origin. We have one that cuts just above it. And then we have one that cuts just below it. But the lines are all what? Parallel. And then D, look at D. We have a line that does not, there's no line there that cuts through the origin. All of the lines, they cut through somewhere else. But what do you see, or what do you observe? All the lines are actually what? Parallel to each other. So we are seeing for all options A, B, C, and D, we are seeing the manifestation of lines that are what? Parallel to each other. But now we need to check additional things from the actual graphs. Let's go and check those additional things from the graphs very quickly. So I'm going to remove these graphs, and there you can see it, guys. So we have y is equal to 2x. Y is equal to 2x plus 1, and then y is equal to 2x minus 1. Now let's note something here. Y is equal to 2x. First and foremost, the equation in standard form, M stands for the gradient. And as you can see, the gradients for all your lines are the same. This is 2, this is 2, and this is 2 in the standard form. So what does that mean? It means that if we have equal gradients, guys, gradient of line 1 is equal to the gradient of line 2 is equal to the gradient of line 3, and they are all equal to what? 2. 2, 2, then it means that these three lines are what? They are parallel. These are parallel lines. So what we can see from A, B, C, and D, all of these show parallel lines. So it would be easy for us to assume that, okay, all these options work. But let's look at the details. Remember, we said M stands for gradient, but what does C stand for? C stands for the y-intercept. I repeat, this is where the graph cuts the y-axis. Now let's look at this one. Y is equal to 2x. What is the y-intercept of y is equal to 2x? Guys, it is 0 here. Okay, just that we don't see it there, but it is 0 there. So in other words, the graph is supposed to cut this one. It's supposed to cut through the origin. Okay, so now I'm going to look at all my graphs and see which graphs cut through the what? The origin, 0. This one does, so A is a possible option. This one does, yes, so B is a possible option. C, this one does, C is a possible option. Look at D, guys. None of these lines actually cut through the origin. So that means I can eliminate D. It's not even an option that I can go to, because why? I see that my graph, my three graphs, out of the three graphs, one of them should actually cut the y-axis at 0. So A, B, and C do that, but D, none of the three lines cut through the origin. So that means I'm going to suspend D. It's not even an option I'm going to go to. So let's look at A and B and C and go back. So all of these have a line that cuts through the origin. Now let's go to the next one. This one has a y-intercept that is positive 1. So in other words, this particular graph should actually cut the y-axis where y is positive. In other words, it should cut the y-axis up here somewhere, okay, above the x-axis. Okay, now let's look at A. A does not have any of these three lines cutting above the y-axis. In other words, above the x-axis, meaning where y is positive. So that means A is also going to be out. Why? Because it does not show me a line where the y-intercept is cutting where y is positive. Okay, so that means this one is also out. Okay, though here, if we look at this line, this shows that the y-intercept should be a negative value, meaning the graph should cut the y-axis somewhere here below. So what I'm saying is that A shows me a line that's sort of like this. It also shows me a line that is like that, because I can see this line cutting there where y is negative. But then there's a second line that also cuts where y is negative. But look at this. This is positive. So A is out. I cancel A. Not even going to consider A. So A and D are gone. Look at B. B shows me this line. There it is. This line, there it is. That line does not exist. Why? Because this one, I should have a line, a third line, where the line cuts through here somewhere. Where y is negative. Y is negative, guys, below this x-axis. So it should be that there should be one of the lines cutting through this area, but there isn't a situation like that. So that means B is also out. Not even going to consider it. So my last option that I see is C. Now let's look at C. Is this graph accommodated? Yes, there it is. Cuts through the origin where C should be 0. The y-intercept is 0. Very good. So that means we've got this line. What about where C is positive 1? The graph cutting through where y is positive. There it is. So that means we are accommodated in that option. Then lastly, where C is negative 1, in other words, where the y-intercept is negative 1, we are accommodated with this line because it's cutting through where y is negative. So 1, 2, 3, it means C is the answer. Okay. All right. please guys, this is very important. All three equations in the standard form have a gradient that is 2, 2, 2. That means the lines should be parallel. For A, B, C, and D, all the lines are parallel. But if we look at the specific gradients, positive lines, positive gradients, that means increasing lines. All three are increasing, all four are increasing. Look at the y-intercept. This means that the C value should be 0. All right, so that means if that is 0, that's good. Positive 1, none of this is positive 1 because the graph does not cut the y-axis where y is positive, so that's out. C is negative 1. Yes, we have a line that is cutting through where y is negative, but the problem is we don't have this one, so A is out. B, yes, origin, that one. Positive 1, that one. Negative 1 does not exist, so B is out. C, 0, there, the graph cuts through the origin, so 0 is there. Positive 1, yes, cutting through where the y-axis is positive, that's fine. Negative 1, cutting through the y-axis is negative, so C is my option. That is correct. Okay, so I'm going to go and look at the next question. Okay, so I hope there's something we are gaining so far. Let's go to the next question. 1.4. If AB is perpendicular to BC, 1.4 guys, if AB is perpendicular to BC in the diagram below, then find the value of A. Okay, remember, if they are saying AB is perpendicular to who? Hey, AB is perpendicular to BC. What is the value of A? I'm sure you guys can see that there's a 50 degrees there, which is a part of the angle. And then A is the completion of angle B, right? But we are told that AB is perpendicular to BC. What does perpendicular mean? It means that the entire angle of B in total should be 90 degrees, right? So the question then is, what is the value of A? Okay. So 50 plus what gives us 90? That's the question. 50 plus what gives us 90? That will be the value of A. So 50 plus, hopefully we can see it's 50 plus 40, that will give us 90 degrees. So therefore that means A is equal to what? Is it 50? A? No. Is B the right option? Is A equal to 30? No, because 50 plus 30 does not give us 90. Even for A, 50 plus 50 does not give us 90. Is it C? Is C the correct option? 50 plus 40, does that give us 90? Yes, it does. And then D, A is equal to 130, D is absolutely horrendously wrong. So that means C is the right option, right? A is equal to 40 degrees. 50 plus 40 gives us 90. Yes, I am wrong. Very good. So A is equal to 40 degrees because we are told that AB is perpendicular to BC. If they are perpendicular, then that means that that angle B is 90 degrees. The angle ABC is 90 degrees. So 50 plus what gives us 90? Because of complementary angles, 50 plus 40 is equal to 90. So that means A is 40 degrees. So C is the right option. Let's look at the next question. Two lines EG and HF, 1.5. Two lines EG and HF intersect each other at point I. If angle EIH is 60 degrees, and then in the diagram, the 60 degrees is marked, then it says angle FIG is equal to, what is angle FIG equal to, guys? If angle EIH is equal to 60 degrees, then angle FIG is equal to, look at the diagram. Hopefully we can see FIG. Do you see the angle FIG? Is it A, 60 degrees, B, and you see the reason, corresponding angles. B, 60 degrees, vertically opposite angles. C, 120 degrees, vertical opposite angles. Or is it D, 120 degrees, angles on a straight line? Okay. So is it A, 60 degrees, corresponding angles? Guys, are those corresponding angles? If you look at angle FIG, as opposed to the 60 degrees you have in the diagram, are those two angles corresponding? Is A the answer? I know ways A can't be the answer. B, 60 degrees, vertically opposite angles. Yes, guys, I think B is the answer. Angle FIG. Okay. Hopefully we can see that. Angle FIG. Thank you, Tabiso. It is definitely 60 degrees. All right. I just want to make my point clear so that you guys understand. Please, guys, we are told that this angle is 60, this one. We are being asked what is angle FIG. Remember, when they say angle FIG like this, it means they want this angle. What is the relationship between these two angles? We call these two angles vertically opposite. What do we know about vertically opposite angles? When there are two lines that are intersecting like this angle opposite this one are equal. So FIG is equal to 60 degrees. Why? The reason is vertically opposite angles. Please, let's not forget that. So that's why we would say the answer is the option B, as we saw it in the diagram. Okay, so let's be careful about that. Let's not forward. Okay, I hope that makes sense. Okay, let's. Okay, if you guys look at the next question there, it says if AD, look at 1.6. Yes, it is term 3. Listen, guys, this is just a past paper, okay, that was written in the King Cetshwayo District in KZN. It's from last year's grade 9 test. So please, this is not the test that you'll be writing if you haven't written yet. This is just a paper to help us revise. 1.6, if AD is parallel to BC in the diagram below, then Y will be equal to, look at AD, they are saying it's parallel to what? To BC. Then they are saying there, if AD is parallel to BC in the then Y will be equal to will Y be equal to X? That's the first question. B, will Y be equal to X plus 90? C, will Y be equal to 90 minus X? Or D, is Y equal to 80 minus X? Right. So that is the question that they are asking there. All right. And what I want to do is I want to read through this so that you guys can actually appreciate the answer that they have there. Okay. But I'm going to allow you to answer. I see the various options that people are saying there. All right. Let's be very careful when you answer these questions, because the options there, Y is equal to X, A, B, Y is equal to X plus 90, C, where Y is equal to 90 minus X, and then D, Y is equal to 180 minus X. That's the $1 million question. Which option is correct? So let me just remove this so that you guys can see. Guys, there. Okay. Y is there. Okay. They are saying these two lines are parallel. So let's be honest. This x, all right, will have another x here. If we were to actually just, if that's it, then there's another value there. That's, guys, that one is x as well. Then if you look at this x and this y, they have a relationship, guys. There's two angles. Okay, this x plus this y, they complete a what? A straight line, and they share a common vertex. So this x plus this y will be equal to what? 180 degrees. Y angles on a straight line. Okay, I hope that makes sense, guys. So remember, in the diagram, I had that x alone. This x has just been put there by me. Why? Because I can see that there's a relationship that exists between these two parallel lines, where if this is x, that is also x, y, corresponding angles. Remember, guys, corresponding angles, AD is parallel to BC. So that should also be equal to x. So I found this, that it is x. Then there's a relationship between this x and this y. This x plus this y should give me what? 180 degrees. Y. They are angles on a straight line. Then remember, I had options here. Is y equal to x? No. Is y equal to x plus 90? No. Is y equal to 90 minus x? No. But we are going to soon discover, if I make y the subject, what happens to it? What happens to the x? Suppose 180 degrees minus x. This is the answer, value of y. So is y equal to 180 minus x? Yes. So my answer is D. My answer is D. I just want to repeat this because I know some of you are like looking at this and you're like, Guys, we had x there, D, A, C, B. We had y here. And the question was, given this diagram, multiple choice, A, B, C, D, is y equal to x? Is y equal to x plus 90? Is y equal to 90 minus x? Or is y equal to 180 minus x? So what I'm saying is, in the diagram, you are given these two lines that are parallel and this transversal line. So if this is x, I am saying to you guys that I am going to say this also is x. Why am I saying this is x? That is x because I know corresponding angles. The F shape, guys, bottom of the two parallel lines. Bottom of this line, this angle is equal to the bottom of this line. So it is x. Why am I saying so? Corresponding angles. AD is parallel to BC. So that is also x. All right. So I state the lines that are parallel. Then this x plus this y complete a straight line. We know that these two angles, we call them angles that are on a straight line. So I'm going to say x plus y, this x plus this y is equal to what? 180 degrees. Angles on a straight line. Then that means I'm going to then make y the subject. Y is equal to 180 degrees minus x. So that is why from my options, is y equal to x? No. Y equal to x plus 90? No. Y is equal to 90 minus x? No. Y is equal to 180 minus x? Yes. So the answer is D. So I circle D as my option for that diagram. Okay. Let's move on to the next question. 1.7. Which one of the following is not correct for conditions of congruency? So hopefully we know what congruency is. Congruency is when we have the same size given shapes, same size, meaning same angle and same length of side. That's what congruency means. Okay, exactly identical. It's when things are exactly identical. According to the angle and according to the side, the lengths are the same, the angles are the same. So what are they saying here? Which one of the following is not correct for conditions of congruency? So does congruency have SSS? It definitely does. Side, side, side. For two triangles, guys, side, side, side is a case of congruency. So A is a case. Okay? Congruency means when shapes are exactly the same, exactly identical. Okay? Congruency speaks to when you have corresponding angles equal and corresponding sides equal. It's when things are exactly identical, same shape, same size. Okay, so if we're looking at two triangles, okay, there are three cases for congruency. Four cases for congruency. So if we look at A is definitely a case of congruency, SSS. Look at B, RHS. R means right angled, H means hypotenuse, and S means side. That's another case of congruency that we accept and we know is true. Then C, SAA, definitely. SAA is a case for congruency. Okay, so in A, B, and C are all cases of congruency. The one case that is off is D. SSA is not a case for congruency. Okay, so D is the option that is incorrect. D is the option that is incorrect. So if they are asking us which one of the following is not correct for conditions of congruency, it is definitely going to be what? D. D is the option that is incorrect for a case or a condition of congruence. SSA, because that case, if it was to be true, is supposed to be S, then followed by an A. The A must be in the middle, and then the S at the end. So if it was SAS, we would say it's correct. But because it's SA, the order matters. Because this case, okay, can't be written like this. Okay, because for two triangles that are congruent, the side, the angle is always sandwiched in between the two sides. Okay, so S, meaning this side is equal to that side, that's S. The A, the angle in between. In the diagram, it must show being in between. That's A. And then the S, this side is equal to that side, the S at the end. But if it's like this, it's incorrect, guys, because the order matters for when you have one angle and two sides. If it's two sides like this and an angle like this, then we are not considering it as a condition that is true. This is off. But these ones, SSS, let me just quickly show you that these ones are 100% correct. Okay, this side is equal to this side, that's S. That side is equal to that side, that's your second S. And then that side is equal to that side, that's your third S. So this is a case that is correct. RHS, what does R stand for? Right angled. In other words, 90 degrees. That's what the right angled means. Right angled. So the right angled R, H, hypotenuse. Remember, in your right angled triangle, your hypotenuse is always opposite the 90 degrees. Opposite the 90 degrees, you have your hypotenuse side. This side is equal to that side. That's your H. Your right angle is your 90 degrees, 90. Your H is your hypotenuse side, opposite the 90 degrees. Your S, any other side of the triangle. This is your RHS condition that satisfies congruency. Then SAA. S, meaning a side. AA. This angle is equal to that angle. That angle is equal to that angle. So hopefully you can see as well. Side, that side equal to that side, that's S, angle, this angle equal to that angle equal to that angle. So basically that is our third case of congruency for grade 9. So that's why, guys, we say which option, according to that question, they asked which option, and we said option what? D, SSA is out. So that means we are going to choose which one of the following 1.7 is not correct for conditions of congruency. It is D. D is not correct. Okay, moving right along. 1.9. If triangle ABC, now if you have three lines that are vertical like that, those three lines that are vertical stand for similarity. So if triangle ABC is similar to triangle PQR, then one of the following is not correct. Then one of the following is not correct. Which one is not correct? That is the question that we want to know. I think even the English there, the way they wrote it, it's I don't know. The person who was setting this paper was Gogai. Where's the English here? Okay. If triangle ABC is similar to triangle PQR, then one of the following is not correct. I think they were supposed to say, then one of the following is not correct. Let's see which one is not correct. Okay. Which one, guys? Those people who are in grade 9 must know which one is not correct. Okay, first and foremost, do we all understand what similarity means? Okay, similar triangles are triangles that have corresponding angles equal. The sides are not equal, but we say that the sides are in the same proportion. I repeat, similar triangles are triangles that have equal angles, okay, corresponding equal angles, but the sides, we don't say they are equal, we say they are in the same proportion, or we say they are in the same ratio, or we can say they are in the same fraction. Same ratio, same proportion, same fraction means the same thing. Same ratio, same proportion, same fraction. Okay. Now, the first thing that they are saying there is AB is parallel. Sorry, AB over PQ is equal to BC over QR. Is that correct? Because we want the one that is not correct. Is AB over PQ equal to BC over QR if the two triangles are similar? Yes, Buru. Buru is saying yes. Yes, 100% correct. Okay. Is AB over PQ equal to BC over QR? Yes, it is. Guys, let me show you why we say so. If triangle ABC is similar to triangle PQR, then remember, what did I say? I said that the sides are in the same proportion. That means AB over PQ. Look at the order. AB. We don't say AB is equal to PQ. No, we say AB over PQ. The fraction, the ratio, the proportion. AB over PQ is equal to BC over QR. Do you see this? AB, if these two triangles are similar, AB over PQ is equal to BC over QR. We would even say additionally it's also equal to AC over PR. It's like the eyebrows with the smiling face, as one particular person who once joined my live said, AB over PQ is equal to BC over QR if the triangles are similar. So this one is correct. This one, we know it's correct. It's sorted, this one. We are looking for the one. If ABC is similar to triangle PQR, then one of the following is not correct. We want the one that is not correct. This one is correct. So it's not the option that we are going to choose. Let's look at B. AC over PR. Let's check. AC over what? PR. First and last over first and last. Yes. Is equal to BA over who? Over QR. Hi, guys. Is this one correct? BA. This is BA. BA over QR. Is that correct? I corner. This one, it's giving not correct vibes, this one. It's giving not correct vibes, this one. Because BA should be over who? BA should be over PQ. Do you see that? Because remember, AB should be over PQ. Or in other words, BA should be over QP. But here, we're saying BA over QR. I corner. This one is not correct. So I'm definitely going to say this one is not correct. But let's look at the other option just so that we can confirm that for sure B is our wrong one, which we are going to choose. Look at this one. So this one speaks to this thing, this idea of same ratio or same proportion. I said this means the fraction is equal, guys. When the triangles are similar, we say that the sides are in the same proportion, same ratio, same fraction. So this here is talking to that. Okay? Then remember, the other part of similar triangle is that the angles, the corresponding angles are equal. Just as the corresponding sides are in the same ratio or proportion, we say that the corresponding angles are equal. Let's check if that is the case. They are saying angle C is equal to R. Where's angle C? It is the last letter. So last should be equal to last. Is angle C equal to angle R if the two triangles are similar? Yes. So this is a correct option. Last equal to last. For what? For similar triangles. So this makes sense. Let's look at D. Angle A is equal to angle B. First is equal to first. First is equal to first. Angle equal. Is this true? Yes. So let's go back to the statement now. What did they ask? If triangle ABC is similar to triangle PQR, then one of the following is not correct. Which one? Is it A? No, A is correct. Is it B? This one is not correct. Is it C? This one is correct. Is it D? This one is correct. So which answer should I be choosing? B. He is not correct. Okay. Are we good? I hope this is making sense to all of us. Okay. Let's move on to the next question. Okay. Sorry, second last. So you see now, similar triangles, we need to understand very well. Look at 1.9. Which one of the following is the property of a guide? You are Puru. Okay, please let me know how you wrote. Inbox me after you've written and let me know how you wrote. I'm glad that you're 100% ready. That's a very good vibes. 1.9. Which one of the following is the property of a kite? A. Two pairs of opposite angles are equal. Do you see that? Two pairs. I hope you understand when they say two pairs. It means the two opposite angles are equal. So, okay. B, opposite sides are parallel. Do we have parallel sides with a kite? C, two pairs of adjacent sides are equal. Now this one is making a bit more sense. two pairs of adjacent sides are equal. D, opposite sides are equal. Yeah. So for a kite, which one of the following is the property of a kite? Is it A? Is it B? Is it C? Is it D? So A is out because for a kite we don't have two pairs of opposite angles that are equal. A kite has only one pair of opposite angles that are equal, and it's basically the two angles that are basically joined by the short diagonal. The two angles that are joined by the short diagonal are the two angles that are equal. So it's only one pair. So A is wrong. It's not two pairs. It's one pair of opposite angles are equal for a kite. B, opposite sides are parallel. A kite doesn't have sides that are parallel. So B is out. C, two pairs of adjacent sides are equal. Yes. What does the word adjacent mean? It means the two sides that are next to each other. Are those two sides equal? Yes. So two of the pairs of those adjacent sides are equal. So C is correct. D, opposite sides are equal. No. It's a no. So C is the correct option there. Okay. Then lastly, 1.10. ABCD is a trapezium. Then look at the options. If it is a trapezium, okay, and that's very important. You see, when they say this statement, in your head you should be able to write or draw a trapezium so that mentally you can see what they're talking about. Then when they are saying what they are saying, okay, because I just want to talk about orientation of a diagram. A, B, C, D, because someone will be like, how can I see the diagram if I don't, there's no diagram drawn, but how can I see it? So they are saying AB is parallel to CD, AD is not parallel to BC. So if AB is parallel to CD, then it means AD is not parallel to BC, and AD cannot be equal to BC. Then B, AB is parallel to DC, AD is not parallel to BC, and they are saying AD is equal to BC though. Right. Then number C and D are so not going to be even considered if you think about it, because C and D, we don't have E in the diagram. So if you're saying AE, A, B, C, D is a trapezium, my question is, where is E? Okay, so C and D are not even going to be options that I'm going to be looking in the direction of. Why? Because I don't have E in the diagram. Remember, the trapezium is trapezium A, B, C, D. So that means the only two options I have are A and B. So now the question is, AB is parallel to CD. Okay, yeah, that order, even if you look at A, not giving. AB is parallel to DC. Okay, so let me just show you something, guys. I just want to write this. I just want to show you something very quickly. I'm just gonna, AB is parallel to DC, AD is not parallel to BC. So I just want to show you this. So if they say D, you see when they say trapezium A, B, C, D, the orientation is everything. You're saying A, B, C, D. So in my head, I can see, because the order A, B, C, D, that is the trapezium that they are talking about. So can we say that AB is parallel to CD? Okay. You see, it's very important. If you're saying AB for the orientation of this diagram, you're saying AB is parallel to CD. It's better to say AB is parallel to DC. Look at the order. This is AB, this is DC. So this option B, is more accurate for me. AB is parallel to AB is parallel to DC, not AB is parallel to CD. No, it's AB is parallel to DC. Secondly, AD is not parallel to BC. AD is not parallel to BC. That's true as well. And then lastly, AD is equal to BC. It's possible, guys, to have AD being equal to BC. It's very possible because we call this an isosceles trapezium. Okay, it's very possible. Okay, so that's why I tend to lean towards option B, not A. Look at A. They're saying AB is parallel to CD. AB, CD, AB, DC, the order is important. AD is parallel to BC. No, AD is not parallel to BC. Okay, and AD cannot be equal to BC. That's not true. So AD can be equal to BC at some cases. In some instances, it's possible that it can be the case. Okay. So I think we are done with that question. That is option B. I would choose option B, of course, for those obvious reasons. And I would leave it there. Okay, guys, I think with the remaining few minutes of this, live, I'm just gonna look at these. I'm not gonna really do them, but if you look at 2.1, it says given the following graph that is defined by y is equal to negative x plus 1, write down the coordinates of A and B. Now, hopefully, we know what it means when they say write down the coordinates of A and B. Look at A. Where is A? Hopefully we can see, A is the y-intercept. That's where we let what? We let x be equal to 0. So if we let x be equal to 0 there, okay, in the equation, we let x be equal to 0. Then it means that we substitute 0, we get y is equal to 1. So the coordinates of A are 0 and 1. Make sense? 0 and 1. To find the coordinates of A is 0 and 1. You would write it in brackets. You write the letter A and you write 0 and 1 in brackets. Then, if you go to B, thank you, Buru, thank you. I think people need to know that there are definitely grade 9 apps that you can download, and maybe you can give them the actual name of the app so that they can download those apps, because I see a lot of people asking me for the question papers. But there's apps, guys. You 2K young generation, the apps are there, you must use them. Then B, look at B. B is the x-intercept. Remember, the x-intercept is where we let y be equal to 0. So you go to the equation, you let y be equal to 0, you transpose the positive 1, and then you divide both sides by negative. Your x value is going to be positive 1. So B is 1 and 0. Okay? Positive 1 and 0. Those are your coordinates. Okay? Yeah. So let's, where A is, where B is, y-intercept, x-intercept, let's always know what it is that ought to be done. Now look at 2.2. 2.2.1 says use the graph drawn above to determine its what? Its gradient. What's important here is being able to first know what are the coordinates of the points that you have there. You see the graph has a y-intercept of 6. You can see that. The graph has the y-intercept of 6. And then it also has an x-intercept of 2. Okay. And if you write down the coordinates for the y-intercept, you have 0 and 6. If you write down the coordinates of the x-intercept, you have negative 2 and 0. How important it is to note where the line is cutting. That line is cutting where x is supposed to be negative. You are looking at the actual line and you are thinking you have 2 that is positive there. No, guys. Look, the x-axis on that side is a negative x-axis. So you must be very careful when you write down your coordinates. Okay, that might look like it's positive 2, but when you know that there on that side, on the x-axis, the x is negative. I think, of course, the person who was compiling this question paper may have omitted to write the negative, but when you must know these things, So I am sure, for instance, that the y-intercept is 6, and the coordinates of that y-intercept are 0 and 6, because the graph where it cuts that y-axis at that point is supposed to be a positive y value. Then if you look at the x value, 2, it's supposed to be a negative value. So the coordinates are supposed to be negative 2 and 0. Then how do we calculate gradient? Hopefully, guys, we know that to calculate gradient, m is equal to y2 minus y1 over x2 minus x1. So 0 and 6 are the coordinates for the y-intercept, negative 2 and 0 are the coordinates for the x-intercept. And all I do is I say this is my first point, so this is x1, y1. And then since this is my second point, I say this is x2, y2. And all I do is I come here to the formula and I substitute. So m is equal to the y2, that's 0. The formula has a minus sign already. y1 is positive 6, so I just write the 6 there. x2 is negative 2. Minus sign in the formula. y1 is 0. What's 0 minus 6? It's negative 6. Be very careful, guys. Negative 2 minus 0, that's negative 2. What's a negative divided by negative? It's positive. What's 6 divided by 2? It's 3. So the gradient is equal to 3. And that's that. Done and dusted. So you calculate the gradient. And does it make sense that the gradient is a positive gradient? Yes, because remember, when the gradient is positive, what kind of straight line are you expecting? You're expecting an increasing straight line. So that makes sense that my gradient is positive. The diagram itself, when I saw it, so this makes sense. Okay. Then 2.2.2, they're asking the question, state whether the function is increasing or decreasing. Hi guys, for 1 mark. Hi guys, for 1 mark, state whether the function is increasing or decreasing. Hi guys, surely you know 2.2, but the function, is it increasing or decreasing? Surely you should know. Okay, so it's definitely increasing, that one. It's an increasing line. Then look at 2.3. The following is the table of x and y ordered pairs, so your coordinates, in other words. Use these ordered pairs to plot the given points as well as the graph in your answer script. Note that x and y are elements of real numbers. So you have a table there. You have x, your x values, negative 2 and negative 3. So hopefully we all know how to use our table to formulate ordered pairs. Hopefully we know how to use the table to formulate our ordered pairs. Okay, so important. We know how to use the table to formulate our ordered pairs. And then we can use those ordered pairs and then go to our graph as it is given to us and then use it to actually sketch the available points on the graph. So important. When we are able to do that, then our straight line is able to just materialize nicely. Okay, I'm just gonna do a rough here. May not be as accurate. So guys, from the table, because this is 4 marks, bye Buru, all the best for your test. I know you're gonna kill it, and please let me know when you actually come back how it went. I believe in you, believe in you big time. So yeah, you see from the table, x was negative 2, the corresponding y value is negative 3. So this is my ordered pair. If I go now, where is x that is negative? X that is negative is here. Where is y that is negative 3? That is there. So where are the two meeting? Remember, x is negative 2 is all the way on this vertical line. X that is negative, y that is negative 3 is all the way. They meet here. This is our place of meeting. Negative 2 and negative 3 meet there. Negative 2 for x, y, negative 3, we meet there. Negative 1 for x, that's there. Negative 2 for y, that's there. Where are they meeting? You see, x negative 1 is here, y negative 2 is there, we meet there. You see? 0 and negative 1 here. Okay, because that's the y-intercept. X that is 1, that's there. Y that is 0, that's the x-intercept. We are meeting exactly there. X that is 2, x that is 2 is everywhere on this vertical line where 2 is, and then y that is 1. Y that is 1 is everywhere on this horizontal line. We are meeting there, you see? And then all I do is I take my ruler and I connect them dots, okay? Since they said x and y are elements of real numbers, it means I can exceed those points and go beyond, because y is an element of real numbers. Guys, this is very important, that when you take your table, if you want to sketch point by point, x is -2. X is -2 is everywhere on this vertical line. Y is -3. It's everywhere on this horizontal line. Where do they meet? They meet there. X that is -1, that's everywhere on this vertical line where -1 is. And then y that is -2 is everywhere on this horizontal line. Where do they meet? They meet there. It's like when mom and dad met on their date, and then basically you came about. Your existence is not, you do not come from, yeah, there's no magical thing that happened, but two people met at some point, you know. Marriage happened and then you were conceived. So that's why I'm saying x, y, where they meet the point. X that is 0 is everywhere on the y-axis. Y that is -1, we are meeting exactly there at -1. X that is 1, everywhere on this vertical line. Y that is 0, on the x-axis, we are meeting there. X that is 2, everywhere on this vertical line where 2 is. Y that is 1, everywhere on this horizontal line, we are meeting there. Then you connect those dots. That's your straight line, and that's that. Guys, really, to the point, okay. Then there's dual intercept method, guys. Like, I mean, dual. Yeah, if you look at 2.4, they say use a dual intercept method to sketch the graph of y is equal to 2x minus 2 in your script. Show all your working. Dual intercept method, hopefully we know what dual intercept method means. It's when we use the x-intercept, where we let y be equal to 0 for the equation we solve, and then we use the y-intercept as well, where we let x be equal to 0 and we solve. We get the points, and then we connect those 2 points. That's it. And we connect the 2 points that are there. Okay. Then 2.5, very interesting question. 2.5 there. Consider the following linear graphs. Determine the equations that define the 2 graphs. How to find the equation of 2 lines. Okay, now that should also be no. Okay, shouldn't be a real hassle. How to find the equation. Remember, to find the equation of a line, we need 2 things. We need the gradient and we need the y-intercept. When we have those, guys, we are done. If we have the gradient and then we have the y-intercept, then the equation is easy to find. Okay, very easy to find. And with these 2 straight lines that I'm seeing here, I think there's no hassles really. All right, look at this straight line. This one, this straight line is cutting through the x-axis at the origin. Okay, yeah, this one. So it's easy. This one I can go ahead and first find the gradient. Okay, there's my points, -1 and -2. And then obviously there's 0, 0, which I know are my origin. Okay, and then I can say this is x1, y1, my first point. This is x2, y2, my second point, so I can find the gradient, right? Y2, 0, minus sign in the formula. Y1, remember, it's -2, so I'm going to write the -2 in brackets because there's another negative there. Over x2 is 0, minus x1, -1 in brackets as well. Then I'm going to the sign, negative times a negative, that's positive, negative times a negative, so that's 0 plus 1, so it's 2 over 1, which is 2. Does the gradient positive 2 make sense? Yes, it does, because this is an increasing straight line. So now I can write down the equation. Y is equal to 2x. Remember, there's a c there, okay, which stands for the what? The y-intercept. I already know what the y-intercept is. It is 0. So I'm going to write y is equal to 2x plus 0. So I can leave it like this, or I can say y is equal to 2x just alone without the 0, because at the end of the day, that means the same thing. So that's the equation of this line. Then I want the equation of that line. I'm going to do the same thing. First, let's identify the points. That's 0 and 4. Then the other point is 2 and 0. Then I find the gradient. M is equal to y2 minus y1 over x2 minus x1. Then who's my first point? Say this is my first point, x1, y1. Second point, x2, point, x2, point, x2, point, x2. Minus y minus 0. Negative 4 divided by 2 is 2. So my gradient is negative 2 here in this situation. So I write the equation in standard form. Y is equal to negative 2x plus c. But remember, what is this? My c value is the y-intercept. So if I have the y-intercept, which in this case I can see, the graph cuts the y-axis. This here, this y value is my y-intercept. Okay, so that means 4 is the y-intercept. So I can say y is equal to negative 2x plus 4. That is the equation of the two lines. Okay, makes sense? The gradient, does it make sense? Yes, because this is a decreasing line. And then I used the points to basically write the equation. Okay. Yeah, guys, I'm going to have to love and leave you, unfortunately, here at this point. But yeah, that was kind of like a brief for this paper. I think I'll have to continue this paper at some other point. I know some of you are writing today, so everything of the best to those who are writing today, and thank you for those who joined. I'm going to have to love and leave you. Take care, have a good day, and God bless.